Hello. Today we're going to talk about some changes that were made to the NFT smart contract platform to improve the overall security and performance. So one of the things we've done is we've added some tests, we've improved the code, we've added checks that allow you to define the parameters that the functions accept, and we're going to talk through that now. So one of the most obvious things that we did was we improved the Solidity code, which is used for the smart contract. As part of that, we installed in our editor a Solidity plugin that basically gives us a lot better syntax control, highlighting pointing out errors and things like this. Very useful when you're developing because you can see the syntax as you're writing it to see if it's compliant with the standards. So that was one thing that was useful. Also within the code, we've added quite a few things. So we've added a lot of these require statements with error clauses. So if the functions detect or have parameters that aren't provided or the parameters are incorrect, we'll bail on the contract and we won't try and process anything else. So this is invaluable for security considerations. A lot of smart contracts get hacked. A lot of people enter bogus data to try and manipulate the contract into doing something else. So one of the things we've done is we've defined boundaries and errors that can improve the kind of security of the contract. Again, we're extending from the Open Zeppelin contracts, which are standard vetted security audited contracts, and we're basically extending that for our own needs in our Chainblock contract. So as you can see here, here's an example of some of the require cases. If the description has to be greater than 0 and it can't be greater than 2048 characters. Essentially, that gives us a bound on the input that someone can enter. We don't want someone entering in, hundreds and hundreds and hundreds and thousands of characters. And likewise for the name, we put a max cap of 100 characters on the name. Obviously, whoever calls this smart contract will have to pay the gas fees, but we want to put those boundaries up. And also, for instance, the skill level in the UI, we only allow you to enter 5. So we've hard put a limit in on the skill of 5 for this character. We've also added a lot more comments to kind of explain what the code does. And you can see here more require statements for get price. We've made sure that the token actually exists rather than trying to request a token that doesn't exist. The reason why here is that anyone can arbitrarily enter in any data. So we want to check that it's at least a number that's greater than 0 to stop overflows and underflows. And essentially that the token ID is less than the max number of tokens that we support. So we don't want them to get a token that's outside of the range. And as you can see, there's a lot more like this the whole way down. We ensure that the IDs are correct, that we're not in range anytime we allow any input to request data from the contract. As part of that, we've actually added a bunch of tests as well that test those parameters to ensure that the conditions are actually accurate and that they fire correctly. So the test on the right-hand side here is also being updated. As you can see, we've got all the different if-else conditions here that test the different characters. So we're sending in bogus data, sending in no name, sending in no values, sending in data that's over the required amount. So for instance, in this case, we're sending in 101 for the price, but the price is capped at 100. So it's capped at 100 here. So what that's basically doing is that's making sure that no one can enter things and that the required statements are correct. So that's part of how we've improved the smart contract. The next thing we're going to do is look at how we've improved some of the code. So what we've done is there's a couple of things that were in the initial version. The initial version was essentially a prototype, and in this version we've improved the security considerably. So one of the things we've done is we've removed some hard-coded API keys that used to be in here. So what we've done is there used to be an Infura API key here. And if this app was hosted publicly, anyone could open developer tools, look at the Infura API key and get, utilize your Infura account to access, free Ethereum RPC endpoints or whatever, and use your account. So one of the things we've done here is we've put in a comment here because in a production system, essentially what we could do is we could use our own node, and that node could have a whitelist functionality or a reverse proxy that essentially blocks requests that don't come from the host website via cores. So because JSON RPC can work over HTTP, we'd probably put that in our authentication and proxy layer as part of the node request rather than putting API keys into our HTML code. That's one thing we've done here. We've also extended the code to add a lot more validation and type checking for inputs. So in our add chainbot function, we've extended our form groups here to add all these validate conditions. So these conditions match exactly what's in our test. They match what's in our smart contract, and it prevents the user from using the user interface to add extra parameters or try and manipulate it. There's still a possibility that they could try and do this, but essentially it's a limiting factor to prevent bogus user input. And you can see all of the different form groups. We've applied regexes and we've applied errors to explain what's happening, and we set some required fields to make sure everything's required. So that's an improvement on the overall UX. We'll quickly demo how that works. So again, the great thing about Web3 applications is there's no backend database, there's no backend server, it's all static HTML and JavaScript, which can be used via MetaMask and public private key technology. So essentially a static web page can be hosted and there's no backend server to exploit, which is great for building decentralized applications. But obviously the smart contract and the node that these applications talk to is the attack vector in this case. So with our app, the only thing it can work with is MetaMask. It's designed specifically to work with MetaMask. So what we're going to do is we're going to log in with MetaMask, and we have to authorize ourselves to sign this application so we can use it. So log in with MetaMask. We've got our application here. A couple of warnings about packages that are deprecated. Obviously, we'll need to upgrade those in a later revision. Just get rid of that for the moment. So there's no chain bots. We're going to create one. And this is the form that we spoke about earlier, where there's where there is user input type. So one of the things we're going to do here is between 0 and 1 characters. So 100 characters. So we're going to paste in 100 characters and of all different types. I'm going to paste in the URL. As you can see, the error says only consists of numbers and letters. Okay, perfect. Let's put in some spaces. Okay, not allowed spaces. Put in some special characters. Again, not allowed special characters. So what we'll do is we'll put in the name, test bot. So we've allowed spaces and characters, but there has to be spaces and characters. So we're going to put in skill. Let's put in 0. Okay, we're not allowed 0. We have to put in a number. We put in a number less than 1. So we'll put in 1. Okay, perfect. Can we put in 9? No, we can't put in 9. So essentially, 1 will do. Or actually, we'll put in 5. We'll give this character 5 skill. And for ETH, again, same rules apply. Can't put in 0. Can't put in any letters. It literally physically won't let me type them. And because there's no form that posts as part of this request, it's very hard for someone to pop open the developer tools and just ignore our client-side validation. This all gets picked up by React and the Web3 library. So in the background, like there's no exploitation, there's no HTTP requests, there's no forms being posted that I can easily manipulate, and ignore the client-side validation. So I can't put in 101, nope, but I can put in 100. And again, these conditions are exactly the same that are implemented in our test and in our smart contract require statements. And for a description, I can't put in nothing. I have to at least put in something. Again, I can't put in special characters, but I can put in text. This is a demo. Right, so we can add. Again, one of the things with Web3 applications is you have to, sign transactions and interact with the smart contract using Web3. So essentially what I'm going to do now is I'm going to create this, sign it, and my bot has been created. And that's sent a Web3 request to my server, processed on the blockchain, it's hit the smart contract, and so on and so forth. So the next thing we're going to do is, how about when we retrieve? So you might remember from the smart contract code, we put some conditions in there that basically meant that we had to ensure that there was a number being passed in and it was in range of the allowed tokens that had already been generated. So what we're going to do here is we're going to try and put in a request for a token that doesn't exist. That's out of the range, and you can see our smart contract error has returned. That basically tells us that it's an invalid range. So the next thing we'll try is use some text. And again, as expected, in this scenario, because it wasn't a number, our application hasn't even tried to process the request. So if we were to go back to our source code for a moment, we can see that we have this condition that basically tries to validate for errors, first of all, for the form. If there's no errors in the form, we'll try and actually progress to executing the smart contract. And in this scenario, if the contract actually fails or the data fails to get processed, we will throw an error exception. So errors, try catch for failures, and then print the errors. So in this scenario, we detected that the ID was actually incorrect. So we weren't even able to process it. And actually, this is the wrong code. It is in NFTs. It is in the list functions, login, stringbot details. So what we tried to do here is we tried to process the ID on the URL, take off the parameter, test that it's a number and a letter, using regex. If that is the case, the number has at least a value. It's not, it is a number, and it passes our regex, then we will try and process it. So in the scenario, the first example where we had 01, which is technically a number, but it's not in the range of things, it passed all of this execution. We tried to pass it to the smart contract, but our test in the smart contract said that is a token, it's not in a range, we'll return an error. In this scenario where we're entering bogus data that doesn't exist, we don't even send that to the smart contract. And this helps prevent user error. The user is trying to manipulate the smart contract, and essentially we'll throw an error here that says it's an invalid parameter. So, you know, if someone tries to exploit this using spaces and letters and all sorts of things, you should get an error. So that's the smart contract and the UI and how that works. Now we're going to talk a little bit about the project and what we did to kind of test that this project is more secure than it was. So one of the things we've done within our repository is we've added a couple of utilities. So one of them is the SonarQube, which allows you to scan for code linting errors and known patterns or anti-patterns in your code. This is very useful for security scans. It's also useful for pointing out bad code, and a lot of security issues are mostly down to bad code or engineers not understanding that some of the code they wrote is an error. It might work in one system, it might not work in another system. So what we've done is we've added the SonarQube properties, which allows us to configure SonarQube. So we've added the project, we've pointed at the source directory, and we've added some environment variables to the overall repo that allow us to run this in a CI. We've also updated our GitLab CI file to basically call SonarQube as one of our stages. So you've got a Sonar stage, which runs first, then we've got a test stage, and then we publish our artifacts after. Within the publish stage, we actually publish our code audit to a public HTML page. So we'll actually be able to see the result of our security scan. And this is published as part of the repository, as part of the CI. And then we've also included GitLab security scans, which is a very useful feature of GitLab. So they've got a quite extensive security package that automatically, when including the template, will scan your code, it will look for errors, it will look for vulnerabilities, and it will produce a dashboard. So first of all, we're going to look at the SonarQube results. And as you can see, there's no vulnerabilities. The code is quite clean. There's a couple of code smells, mostly small little tiny issues. But one of the other things within our project is we've also got like prettier, which allows the code to be formatted in a standard format. So within our project, we do have some bugs, but once we actually look into these B-grade bugs, we'll realize that most of them are false positives, which is quite a common case in some code. And essentially what we've got with the bugs is to do with HTML with CSS. And essentially what is happening here is the font family isn't, SonarQube is detecting that the font family isn't described, but because we're using SCSS, the font family actually gets included later on, and uses extra modules to pull this in during kind of compilation time. So these are actually false positives, and we could bump these. Even SonarQube is graded them as a D, which is very low. So as you can see back in our issues here, most of these are recurring, the same issue in a bunch of files. So that's kind of SonarQube. As you can see, the report is overall quite good. We've touched a lot of code. and because we're using actually a template library for our UI, there's some bugs in that have been kind of introduced by that library. So we've cleaned some of them up. Some of them we're not going to clean up because it's out of the remit of this assignment. So essentially, as part of our build, Sonar Cube will run, it will generate this report. We fixed all the vulnerabilities, and we've only got some D-grade bugs, which are essentially non-issues. So the next thing we've got is the GitLab Sonar scanner, the GitLab stats security vulnerability report. As you can see, we have quite a few vulnerabilities. We initially had whatever that is, 15, and a few smaller ones. And over the course of our exercise, we cleaned a lot of those up and fixed it. So if we look at that, we've got the actual vulnerability report. And the vulnerabilities that are actually here now are actually part of our code audit output code. We haven't excluded that from our CI, from this scanner, but essentially the actual application source code has been corrected, and these are the results of the scanner. But essentially, this is a good example of what this dashboard would bring. So as GitLab runs the CI pipeline, it runs a bunch of different Sonar, or a bunch of different scanning utilities, and it will look at all different parts of your source code. It will try loads of different things, look for vulnerabilities against known published vulnerabilities, and then it will build a dashboard. And you'll typically see a bunch of gradings, kind of like SonarCube, and then as an administrator of the system or as a developer, I can come in here and I can decide, is this an issue? I can actually see the line of code that it tells me is an issue. And as part of your development lifecycle, you can actually correct these issues and fix them. And any good project won't go to production if there's critical issues or vulnerabilities detected as part of the scan. So this is an essential part of the development lifecycle, and really should be utilized to its full extent. And you can see that the rules that are applied, which is quite interesting. It gives you a example of what these are. So you can see here what it thinks this issue is and what it relates to, and the different CWEs and linting issues that are raised. So that's the actual integration, quite useful for this project. We were able to detect a bunch of poor JavaScript or kind of non-compliant code that just worked but may have a vulnerability or some issue in future. So as you can see in the pipeline, you can see we've got the different checks. We've got the Sonar Cube runner, and then we've got all of the GitLab security scans. And you can see it's checked a whole bunch of things, and it's looked at all parts of our source code, and it's tried to inform us of anything that is poor. And then, as I said, the final part is the publish of the pages that show us the actual reports. These are not the generation of this is not part of our pipeline. So what we've actually used is a third party tool in Kali Linux, and we've imported the HTML into our application for kind of for ease of use, but it could easily be integrated into our pipeline. So you can see here we've got the GitLab pages HTML output for Skipfish is embedded into our project, and as you can see here, the different reports after our fixing of all of the issues. So you can see there's a couple of things that potentially are false positives. Interesting file, jQuery. jQuery is pretty legit. This is pulled from a real source, but Skipfish is thinking it's an interesting file. If you've used jQuery, it is quite interesting. So a couple of other small issues here. Most of these are I would consider false positives. Some are caching directives are incorrect. Because we're using a development Nginx setup, or sorry, Express server setup. It's not a production grade system, so it's flagging some of the caching setup that is in the dev web server as part of the Node.js package, the Express library. The other thing as well is failed resources. Again, you can see here that this is all auto-generated code as part of the development package bundle. This would actually be compiled into a final production minified release, and I'm sure that these false positives would also go away. So that's kind of the report for that. This tool, because React is quite extensively tested, it's kind of, I would say, battle hardened to handle a lot of things like XSS vulnerabilities due to its templated nature and the way it processes data and renders data. So you actually get quite a lot of security features out of the box and coding standards that you wouldn't get with your traditional HTML and JavaScript library. So the framework itself is quite extensive, which means a lot of the things that we tried to test for actually didn't throw issues. So you can see here, it's the same recurring thing across all different parts of our app. So what we did was we tested a couple of different things. We tested the view bot page, which renders, the bots in our web app. We tested the add functionality to see if there any vulnerabilities there, but again, we only got the same kind of issues. And then we also tested the main root of the project. Again, same issues. So within our application, the other thing that we could do and probably should do within our CI pipeline is also add the tests for the smart contract. So we could easily implement truffle test as part of the CI and have a pipeline that basically contains all different parts of the build. So scan the code, lint the code, security audit the code, and then test the smart contract in the CI and make sure all of these things pass. And then at that point, allow merge requests to merge to master or someone to deploy to production. So that's basically a quick high-level overview of the features and the code and the automated scanning that we've implemented as part of this project. And that's how we've extended it and the extra parameters that we've put in. And one of the things that we've tried to be aware of is that someone could circumvent UI validation. So we've implemented the same validation in the smart contract. We've implemented it in React libraries. We've implemented it in tests. And the idea is that at all points, touch points, or possible touch points, we've implemented the same rules to basically ensure that there's less scope for someone to manipulate the code. So that's basically it. That's a whistle-stop tour of all of the features that we've added to this project. And yeah, thanks for listening.